Question 15. Question 15 is what I believe to be a very difficult question. And so if we were to do the official math, which we'll do it towards the end of the video, it's going to be pretty complicated. But if we look at this from a testing point of view, I think this is an accessible question, especially if you understand how to plug in values and how to calculate some things. Looking here, we have x's, right? And we have a bunch of answers. So what we're really going to do is we're going to test these solutions. The reason why there might be two answers is when we're talking about a quadratic, we're talking about what are called the zeros, where does it cross? There can be more than one spot. We don't know if that's going to be the case here. And then we're also going to learn at the end of the video something called extraneous. So this is a complicated question, just know that. But again, from a standpoint of how do we get this answer, let's look for patterns. Again, I have how many negative sevens? Three of them. So the first thing I'm going to do, I guess, is check, is negative 7 the answer? And let's plug that in. 3 times negative 7, and then that's going to be negative 21, but I have to add the number 46. And that gives me the number 25. But note that that number is inside of a square root. So the square root of 25, again, that means what number times the same number is going to make 25, tells us the answer is 5. But I didn't only put a negative 7 in here, I also had to put a negative 7 on the other side of the equation. And negative 7 plus 2 is negative 5. So I do not like that number. So as soon as I see that that is the answer, I kind of can get rid of those three answers. Okay, so then what do we have left? Again, the pattern is there was two negative sixes and there were two positive sixes. So we know it's got to be one of those. Is it 7 also? We can find out. We don't know. Let's test that 7 since we just did sevens. So if I was to come back to the beginning and not do 3 times negative 7, but 3 times positive 7, I get 21. And if I was to add that to 46, I get the number 67. The square root of 67 is kind of a messy number, so we can type that in above the x squared. That means what number times the exact same number is 67? Well, I know that 8 times 8 is 64. 9 times 9 is 80. There's a number in between there. It's a crazy decimal. So, okay, does that crazy number, 8.18, is that going to be the same as 7 plus 2? No, that's supposed to be 9. So 7's wrong, just flat out. Let's test this 6. We know it can't probably be negative 6 now, so hopefully it's 6. Let's try that out. 3 times 6, that's 18. 18 plus 46 is 64. Okay, I like that number because the square root of 64 means what number times the same number? That's 8. Okay, so now I've gotten the number 8. And if I go to the other side of that same equation, what is 6 plus 2? It's 8. That is the answer from a standpoint of logic. Say you're like, I want to test the negative 6 still. Okay, come in. Negative 6 times 3 is negative 18, plus the 46 gets us a number that says 28. Guess what? The square root of 28, it's going to be a decimal. It's kind of a funky number. And so, no offense on the other side, negative 6 plus 2 that's just not the same thing. That is the answer. Now, if I was to pull up the rationale for how HiSet thinks you can answer this, remember, they have their answers at the back of these tests. These are sample tests. These aren't everything. This is the math that they're looking at. So I'm going to do it the long way just to show you how this math is done in Algebra 2, is where I think this is really a question of Algebra 2 level. So because this is a square root, they decide that they're going to square it. But the rules are what you do to one side, you must do to the other. So if I come over here and I square this side, what's nice over here is this cancels out, and I have just now 3x plus 46. The question is, what do we have over here? In my class, we tend to use what's called this box method. It's just a way of organizing. What I first want a kid to know is x plus 2 squared means that I have two of those. And so you have to multiply or distribute the things to both. Some people have been taught that's called FOIL, first, outer, inner, last. But this box achieves the same goal. An x times an x is an x squared. A 1 times a 2 is a 2x. A 1 times a 2 is a 2x, and to get to that final box is 2 times 2, which is 4. There's many ways to solve problems. It's just a tool, and if you like it, use it. X squared, I put the 2x and the 2x together, you get a 4x, and you have a 4. The problem is you have things on both sides, and you need to get everything to one side. So I'm going to move this 3x over, and I'm going to move the 46 over. Then I've set it equal to 0. I have x squared plus x minus 42. Double checking. Sometimes I just want to verify. And so now what they've created is this question that's called factoring. Factoring means what two numbers are going to multiply to make negative 42, but are going to add to make the number in the middle, which in this case is positive 1. This is a lot going on. I happen to know that 7 times 6 is 42, right? And 7 minus 6, or 7 plus negative 1, is also the number 1. So what they do is they say x times x is the x squared. They make you go forwards to then ask you to go backwards. That's what makes this a real difficult question. Because the back is a negative, I know 1 is positive, 1 is negative. Because I want a positive 1 in the middle, I'm going to put the bigger number as the positive 7, the smaller number as the negative 6, because 7 minus 6 is 1. 7 times negative 6 is negative 42. But you're still not done. That's set equal to 0. So then you're supposed to say, okay, x plus 6 equals 0, x minus 6 equals 0. So I would minus 7, and you get the answer of negative 7. You add 6, you get the answer of positive 6. So then a student might ask, well, Gary, doesn't that mean the answer was? It feels like it should be, but it's actually the wrong answer because you're supposed to do what's called test your answers. So what we did at the very beginning, why would someone do all that? No way should you do all that. You have to still test your answers. Well, they gave you all the answers at the beginning. You saw the numbers. So when you plug these numbers in, we ran into that same problem. So they call this extraneous. But again, I don't think you're expected to do all this. And if you can, that's amazing. I think what you should look at in terms of the question is, these are the answers. Let's plug it in and see if it's going to work because it's got to work perfectly. I apologize for the long video. If this is helpful down here and that's what's included in their rationale, good for you. Use logic. You have this test. Be patient and keep working hard.